This tutorial is about some special matrices that we come across in MATLAB quite frequently and some not so frequently, but in some way they will appear when you're working. The first one is called a zero matrix, and what zero matrix is that it's a matrix of all zeros, and you can define this matrix by calling zeros function and telling how big you want it to be. So if you put a single number n, then it creates a square matrix, n by n square matrix. Or you can provide all the dimensions. So let's make a 3 by 2 zeros matrix. So this is 3 rows and 2 columns, and you can see it creates that matrix for you. Similarly, ones matrix is a matrix of ones. So if you say A is equal to ones, let's do a 2 by 3 matrix this time. In a similar way, it will create one matrix of ones of that size. I often use zeros or ones to create also a matrix of constant. Let's say I want to create a matrix of value 3. So I can say ones into, so let's say I want to create 3 by 2 matrix of 3's. I can create ones and then multiply it by 3, and that gives me a matrix of 3's. Or I can do zeros and then add 3 to it, and that's exactly, it'll give the same result. Okay. The other one is called identity matrix. So it's symbolized by I in MATLAB. So I can say I, and I can provide a number. So let's say I want to create a 3 by 3 identity matrix. It will create a 3 by 3 matrix with all the diagonal terms as 1. Okay. Now, at this point, I want to talk about sparse and full matrix. As you can see, if I call this A, then only diagonal terms have non-zero value. Everything else is 0. So MATLAB has a special way of saving these matrices if you want to save the memory, which is called sparse matrix. And the sparse matrix is the one where most of the terms are 0. So you can tell MATLAB that A is a sparse matrix. I'm using sparse here to say create an identity matrix of 3 by 3 and then make it sparse and see what happens. So now instead of saving all 9 values, it's only saving 3 values, which is 1 1, 2 2, and 3 3. So this is much more concise way of saving A. Anytime you try to print A, it is only going to give you the non-zero values of the matrix, and you can assume that everything else is 0. Now you can always convert A back to full by just saying full A, and it shows you the full matrix. And so you can use sparse function or full function to go back and forth. Now there are many other special type of matrices that you can see by just typing help gallery, and in this gallery you will see that there are all sorts of matrices that are available. Some of these are probably not even useful for what we are doing in this class, but a matrix that will appear quite frequently is called a tridiagonal matrix. And what a tridiagonal matrix is, it has 3 diagonals available, and it's always created as a sparse matrix, and it looks something like this. So we have a matrix with a diagonal and then 2 off diagonals. So there'll be some values here. In this case this is 0, but they can be non-zero values in this diagonal as well. So that's called a tridiagonal, and that's what we'll be solving for one of the problems in today's manual. So this concludes this tutorial. there might be some more matrices from this gallery that we will be using. So in order to define tridiagonal matrix, we basically call the gallery function, give it the keyword, and then some of the information about what the tridiagonal values are. So that we will cover that in the next tutorial.